All right, in this video, we are going to be learning about how to find the midpoint of a line. So we can talk about it on a number line, where we have point A and point B just lined up on there. And the midpoint, I'm going to call that point M, will be directly in between points A and B. So the midpoint basically bisects this line segment where this section and this section are exactly equal. That's why I have those lines indicating that those are congruent. So to find the location of M, I'm really just going to find the average of points A and B, which I'm going to call A plus B divided by 2. So remember, the average or the mean is just adding up the values that you have, which in this case is just the A and B, and dividing by how many you have, which is just those two numbers. So that would give us the midpoint M. On a coordinate plane, remember we have an X and a Y, so I'm just going to sketch that. That's my line. This is my line segment from A to B. And my midpoint somewhere in there, again, it bisects that line segment so that this section and this section are identical, they're congruent. To find the actual coordinates for point M, I'm going to label this as x1 and y1, and I'll label this as x2 and y2. You can flip-flop those, actually that doesn't really matter, the order, but you're going to find the average of the x coordinates and the average of the y coordinates, and together that will make the coordinates for your midpoint. So the average of these two x coordinates, which is pretty much identical to what we did there, x1 plus x2 divided by 2, tells us the midpoint, the x coordinate for the midpoint. And the average of these y coordinates tells us the y coordinate of our midpoint. We find the average of the x's, average of the y's. That tells us the x and the y for that midpoint, which actually tells us kind of a lot of information. It tells us that these two are congruent, that distance and that distance are the same, and it tells us the location of point M. We can also work backwards using point M and let's say point A to find point B. We'll get to that. What is the midpoint of AB? So we have A at -4, B at, that's halfway in between 8 and 10, so that's 9. So I'm really just taking the average of -4 and 9. So that would give me 5 on top divided by 2. You could even just leave that as a fraction, but I'm going to say that's 2.5. So directly in between, I'm going to mark 3 there. That is my midpoint M at 2.5. What are the coordinates of the midpoint of EF? So I'm trying to find the midpoint between that and that. So let's call this one x1 and y1, and I'll call this one x2 and y2. Again, that order really doesn't matter. If you want to flip-flop those, it really doesn't make a difference. But I'm going to find the location of that point that's directly in the middle, and then I'm going to plot that point. So I'm going to add together 7 plus 2 and divide that by 2. That's going to tell me my x-coordinate. And then 5 plus a -4, divide that by 2, and that'll tell me my y-coordinate. So that's 9 over 2. I'm going to actually write that as decimal as 4.5. And then 1 over 2, which is just 0.5. So my midpoint is 4. This is 5, that's 4. So 4.5 and a half. Actually, it might have been easier to just leave that as a fraction, but either way, those are the coordinates for what I'm going to label as point M, because it's my midpoint. All right, so now here we're given the midpoint M and one of the endpoints. So we're told that this is at -5, 7. We actually don't even need to be given this graph, but we're given the midpoint and one of the endpoints and their coordinates. So what are the coordinates of point D, which is going to be somewhere down here? basically you're thinking about doubling this distance. If that M is the midpoint, then this segment and that segment, I'm not sure exactly how far that goes, but I know it's the exact same distance as that. So there's two different ways you can do this. One is actually just setting up the equation. I'm thinking about this as my x1 and my y1, and this is really my answer to the average of x1 plus x2. There's some x2 and y2 down here that I don't know yet, so I'm going to just keep that as a variable, divided by 2, but I know the average of those is -2. I'm going to do the exact same thing for the y-coordinate. I have 7 plus this y2 divided by 2, and that equals this one. So if you solve those two equations, I'm going to multiply that by 2 to give me -4, to give me -5 plus x2 equals -4, and then I add the 5 over to give me that x2 is 1. I'm going to do the exact same steps here, multiply by 2 on both sides. That gives me 7 plus y2 equals 2, and then I'm going to subtract 7 from both sides. That gives me y2 equals -5. So my coordinates there are 1 and -5. Another way to do this, which I think is a little bit easier, is to kind of just think about extending this. If I'm thinking about that as the same as this, I could really just double the distance here, both the horizontal, that distance, and the vertical, that distance, and just kind of extend that. If this is 1, sorry, I shouldn't be counting that one, sorry, 1, 2, 3, then it's just going to continue that direction, 1, 2, 3 in that direction, and you see that that ends up also at 1. Same kind of thing for this vertical distance. I'm counting 1, 2, 3, 4, 5, 6 to get down really from 7 down to 1. So I'm just going to continue that, 1, 2, 3, 4, 5, 6, down to -5. So you can think about really just doubling this horizontal distance that way and the vertical distance that way, or you can actually set up the equations and algebraically solve for that set of coordinates. All right, so we are going to use that diagram to answer the questions below. D and E are the midpoints of AC and BC, respectively. Round to the nearest hundredth. What are the coordinates of D, E, and then actually we'll get to that later, but that is saying that this is the midpoint of some AZ, where Z is somewhere down there, and I want to find the coordinates of Z. So to find the coordinates of D, I'm going to find the midpoint of A and C, which means I'm going to add together 2 plus -4, divide that by 2, and 18 plus 6, and divide that by 2. So that would give me -2 over 2, which is -1. That would give me 24 over 2, which is 12. I'm going to do the exact same thing for point E using B and C. It's the same thing. I'm finding the average of, I'm going to write this here, 4 plus -4 divided by 2, that's going to be 0. And 6 plus 12, I guess I flipped the order, but it doesn't really matter. So I'm adding those together, that gives me 18 divided by 2 is 9. So the coordinates of E are 0, 9. And the coordinates of D are -1 and 12. You kind of want to just make sure that that actually makes sense. There could be just a silly mistake in here, but going from there to there, that's going up by 3, and then up by 3 again. Going from here to there, that's going up by 6 again. It should take the exact same jump because those line segments are congruent. Same kind of thing here. +4 to go from this x to that x, and +4 again to go from that x to that x. And I'm going to do that one more time. From 6 to 9 to 12, it's making a vertical jump of 3 and another vertical jump of 3, which confirms that those two line segments are congruent, and that means E is in fact the midpoint of B and C. I'm going to erase all this, otherwise it's going to get messy. So I'm looking for now the coordinates of Z. I know that C is the midpoint of AZ, this hypothetical line that I'm drawing, line segment that I'm drawing there, where I'm just extending that. It's supposed to be a dotted line. Kind of ran out of room. That's definitely not the same, but it doesn't really matter. I'm not drawing it to scale. That line segment and this line segment will be the exact same length. So I'm going to show this in two different ways again. I'm thinking about the horizontal jump from 2 down to -4. That's going down by 6, so I know I just need to go down by 6 again. So to get to z, I'm going to go down by 6 again to get down to -10. Same exact thing for the y. The vertical drop is going from 18 down to 6. That's dropping by 12. I'm going to just continue that and drop by 12 again. Gives me a -6. I think that's way easier than setting it up algebraically, but again, you can set this up as the answer to the average formula. So I'm going to say x1, I guess I'm using this as x1 and y1, plus 2, which is my x2 and y2, divided by 2. That equals -4, and y1 plus 18, which is my y2, over 2 equals my midpoint for the y coordinate, which is 6. I'm going to solve each of these. Actually, I'm going to do this at the same time. Times 2 equals -8 times 2. Oops. So I'm multiplying by 2 on both sides. That gives me 12 on that side. And I guess you can probably see where this is going. We're going to subtract 2 from both sides, and you get the x-coordinate for z is -10. And you're going to subtract 18 from both sides here. And you get that the y-coordinate for z is -6. Excuse me. This, setting it up algebraically, maybe it's not so important when these are all numbers, but when they're algebraic expressions, this is actually going to be an important formula for you to be able to digest there. So this one is just kind of analyzing this proportional relationship here. The length of xy is 24 centimeters. So I'm just going to draw that x to y. No, I guess I said that backwards, but that's 24. The midpoint of xy is m, which means that this is 12, this is 12. C is on xm, so it's in here somewhere. So that xc is 2/3 of xm. So I know that c is more than half of the way there. And in fact, if you know that this is 12, then 2/3 of that will be 8. So I'm going to label, I got to change colors here. So I'm going to label this section as 4, and let's label this section as 8. It's going to get a little bit messy, but we're trying to find, eventually we're trying to get to length CD. We haven't even figured out point D yet though, but point D is on MY. Let's change colors again. So that MD is 3/4 of MY. So MD is 3/4. It's got to be more than halfway. Actually, it's directly in between these two. It's 3/4 of 12, which means that that's 9. So this section will be 3. This section will be 9. We want to know the length of C, D, which means we're adding together. I guess we don't really even need that this is 24 right now. We just needed that to figure out that these were 12, and we don't need that anymore either. We're really just counting from there to there, which means that CD has a measure of 13. All right, so here we're going to actually represent these with algebraic expressions. A line, oh, I don't like how that's capitalized. A line segment AB has endpoints A, where the coordinates are represented as 8x minus 2, and the y coordinate is 10x. B is represented by those expressions where that's the x coordinate, and that's the y coordinate. Write an expression for the coordinates of the midpoint of AB. So again, I'm thinking about this as the average of these two coordinates, where I'm adding these two expressions together. 8x minus 2 plus 4x plus 12 divided by 2, and 10x plus, I'm going to put this in parentheses, although you don't really need to, negative 3x, oops, I missed my x, plus 4. So I'm going to combine like terms and then simplify as much as I can. Combining like terms on the top here, I would get 12x plus 10 divided by 2. And here I would get 7x plus 4. That's actually not as simple as you can make it, depending on the type of expression we're working with. This might be as simple as you want to get it. You could change this. You could actually divide the 2 into both of these. This one I would absolutely do that because it does divide nicely into both of those. So you could divide this 12x by 2 and the 10 by 2, making that 6x plus 5 as my x coordinate. So I'm going to label this as m. And this, I guess I'll simplify that into, I'm not sure if you would even call this simplifying, but 7x over 2 plus 2 as my y coordinate. All right, that pretty much covers everything that we need about midpoint, both as numbers and algebraic expressions. Hopefully you got what you need.